Hello and welcome to our lesson on radicals explained. First we have to talk about the definitions. What are they exactly? A radical is an expression that means we don't have an equal sign. That includes a number, or you can have a variable, a radical, it's also called a root sign, and an index. So take a look. We've got what's called the radicand inside, you've got the index, the tiny little number on the outside, and then the actual radical sign. Kind of looks like a big check mark. Now there are three parts which we just talked about. The radicand specifically is the number, and it can include a variable that you are taking the root of through prime factorization. We'll talk about that in a second. But that radicand right there, the number 96, it's the number that's inside the radical sign. The second part is the actual radical sign. It's the check mark. And then the third part is the index. And the index is the number of factors in the group that you need to take out for prime factorization. That's a lot, but we'll talk about what it means. It's a lot easier than it sounds. Just know that your index is a teeny tiny number that's directly outside of the radical sign, and the number and possibly variable that's inside the radical sign is called the radicand. Okay, now, if we're looking for 96 as our radicand and they want us to take the fourth root of it, we're talking about prime factorization, which means, if we go back one, we're going to actually take 96 and we're going to break it down. So we're going to take 96 and you're going to prime factor it. Some people call it a factor tree, where you break it down to prime numbers. So what times what is 96? And you could start with any two numbers, it doesn't matter, you're always going to get down to the same prime numbers. I just happen to see that 3 goes into both 9 and 6 evenly. And 3 goes into 96 32 times. This right here, number 3, that's a prime number. I can't factor it anymore. The only other factors are 1 and 3. It gets me nowhere. So I stop there for a prime. However, 32 can still be broken down. So 32, and you can pick whatever numbers you want. This, I'm going to say 8 times 4. 8 is still not a prime number, so I have to break 8 down some more. 4 is not a prime number, so I have to break 4 down some more. 4 gets broken down into 2 times 2. 2 is a prime number. And I'm putting dots under them so I can keep track of where my prime numbers are. Now with 8, you're going to get 2, which is another prime number, and then you're going to get 4. 4 is not a prime, so we still have to break them down. So you're going to have 2 and 2. Look how many primes we have. We have a 3, 2, 2, 2, 2, and 2. So 4 2s and 1 3. And take a look. That's where we got this. Got 1, 2, 3, 4, 5, and then you've got the 3. So what happens is, according to the index, we need to find groups of 4. The index is saying once you break down the radicand, that 96, you have to find out what are some groups of 4 that we could take out. Groups come out and singles stay in. So what that means is we got to look for a group of 4. And there's one group of 4. Those guys are going to come out from the radical sign, and they're going to move to the outside of the radical sign. The answer to the radical expression explains how many times you can multiply that outside whole number, that group of 2's, by itself using the index, that number 4, as a guide. Anything left over inside the radical, that 2 and that 3, you must multiply them back together again and stick them back under the radical sign. They become your new radicand. That's a lot. Take a look. Remember we had 2 times 2 times 2 times 2 times 2 times 3. And they said groups of 4 because the index said take them out in groups of 4. So we took out all 4 of these 2's, and they ended up right there. If you take it out as a group, you only write it one time outside the radical sign. So we had one group of 4 2's, so we just wrote it one time. Now these guys right here are leftovers, so we multiply them together, they turn into a 6, and they became the new radicand. The index is still the same, it's still 4, that's how we got all this stuff. Now, if you need to double check it, which you definitely should, multiply your whole number, in this case it's the 2, the number of times in the index. So they're asking us to take that 2 and multiply it 4 times in a row. So if we do that, we do 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Now you multiply that answer, the 16, by whatever's under the radicand, which is 6. So we're going to take 16 and multiply it by 6. If you do that, you're going to get the answer 96. Does this answer match the original radicand? Think back when they actually asked us the question, 96 was the original radicand. So on our double check, it turns out that this answer right here, all this stuff right here, is correct. Because 2 raised to the 4th power times 6 is 96. That gets us back to the original. Okay, when will you see radicals? Dealing with radicals may seem pretty useless, but they are everywhere. You're going to find them in Algebra 1, in Geometry, in Algebra 2, and even in upper level courses, pre-calc, calculus, all that fun stuff. And just to name a few, you're going to see these radicals when you deal with quadratics, when you deal with the rational root theorem, when you're factoring, and a bunch of other stuff. So getting used to these radicals and working them quick and easy and getting them right all the time, very helpful in all your math classes, especially in high school. Okay, so let's take a quick review. A radical expression has 3 parts. The index, that was that teeny tiny number outside of the radical sign. Then the radicand, that was the number inside the radical sign. And then the actual radical symbol, which was the check mark. The radicand is the number that you need to break down by prime factorization. That radicand number in our example was 96. And remember, we made the big factor tree. So we took 96 and we broke it down. That's the one that you have to prime factor, the one that's sitting under the radicand sign. The index, that teeny tiny number, is the grouping of the numbers from the prime factorization calculation. In other words, once we got all those prime numbers, the 2 times 2 times 2, and it kept going, we had to bring them in groups of 4 because that's what the index told us. That teeny tiny 4 said get everybody in groups of 4 and get them out. Any leftover numbers that can't be grouped together, that was the 2 and the 3 that were left over, have to be multiplied together and put right back under that radical sign as the new radicand. So we multiplied the 2 and the 3 and they went right back under that check mark radical sign as a 6. And that was it. And that's it for our lesson on radicands explained.